Alright, lots of videos I should be making, but I still got physics on my mind. Number 20, so I just think I'll go through some of this, like going from the beginning, explaining why this school of fish analogy is the proper analogy, and a little bit more about gravity and these interactions. And so we begin with an idea. Okay, so there's only two things in the universe by my argument. There's little bits of stuff moving the speed of light, and there's empty space. And moving the speed of light means you move a certain distance, a Planck constant of distance, a Planck distance, in a Planck time bit. But the point is you're moving the speed of light through a medium. The space does exist, but it's nothing. It's just distance. So all there really is things moving at the speed of light and things moving the speed of light, and they're separated by distance, and that's it. So it's basically just fish and seawater. So you can think of the seawater as nothing, but it's something. It's a medium, but it's just a medium. It's all the same. It's just distance between fish, really, and it just provides the medium for the fish to swim in. So if we have an analogy that the fish only move one speed, so we could just say that all the fish move 30 miles an hour, and that's it. And there's just fish, all the same size, moving 30 miles an hour. So that's the starting premise. And that all the complexity is basically just a school of fish inside of a school of fish inside of a school of fish inside of a school of fish. That's what all the complexity is, and each school of fish can have different patterns of movement. So they can move in figure eights, or they can move in circles. They can move in lots of ways and maintain their speed at 30 miles an hour. You might argue that it's going to be difficult for them to move in right angles or to do something dramatic like that. But otherwise you would argue that they can do a lot of different kinds of movements as long as they maintain their speed at 30 miles an hour. They never go any faster, they never go any slower. And that's sort of the rule. Alright, so to bring that back to physics, there was two fundamental arguments against this idea of a photonic pressure for gravity. And the first argument is this momentum argument, that somehow the thing's momentum, a material thing's momentum, would create more force coming into the photons. And the point to be made is that from a photon's perspective, from the fish's perspective, there is no school of fish. It only interacts with individual fish. It only interacts with other fish moving 30 miles an hour. There's no such thing as the momentum of the school, because any momentum the school has only has it because fish are swimming in that direction more than they're swimming in some other direction. So that theme recycles here in this idea that, say, if you have an electron, and let's just say it is some sort of circular thing, it, let's say, has a fundamental nature where it moves. Its natural tendency, like the school of fish, is to wobble, is to not be perfect. I mean, it can be, let's say theoretically, but usually if it's going to have some sort of complexity, it's going to vibrate. It's going to move in lots of directions internally that are going to be reflected in movement externally. And it's only when a certain number of the fish, as stated, are going in a direction that it would tend to wobble in a direction. So there would be a tendency to spiral in a direction, to migrate. And this is the natural tendency, let's say, of an electron. So that could be explained as having, by some mechanism, again I don't have the mechanism for it, but if it had an elliptical orbit, not a perfect circle, you could understand that the fatter end of the ellipse would bite off more space than the shorter end of the ellipse. and the tendency would be for it to migrate in the direction of the wider end of the ellipse. These two sides would end up being the same amount, so it would wobble a little in this direction and wobble a little in this direction, even move a little bit in this direction, but it would mostly move in this direction. So at the end of the wobble, it's always migrating in a direction. And that the argument I'm making is that gravity is working on this principle. So again, we have to understand that the thing this wobble has, it has two components. It has a direction, and again, even this wobble is going to have a speed. So there's going to be a speed at how fast it gets somewhere. So you could say it has fewer loops and it gets somewhere quicker, so it moves quicker. So you could say an electron can migrate quickly or an electron can migrate slowly. And then what we might call heat is a consequence of accelerating the movement, accelerating the rate of migration in a direction. And this is all now getting a tiny bit complicated. But it's an important distinction between something's angular momentum, its direction, and changing that, something that's already moving, and changing its direction, which doesn't add energy, and making something move faster in a direction. So one you can understand as being intrinsically hard to get rid of, the faster movement, than the change in the direction. Or one, you can see the additive nature of it. You're adding something if you're making something move faster. You're not adding anything if you just change what direction it's moving in. The movement is the energy. Changing the direction of the movement doesn't change the energy. So if I have a fish that's swimming left, or I have a fish and I change its direction to right, I haven't added any energy to the system by changing its direction. But if I change how fast it's migrating in a direction or spinning in a direction, then I have changed, converted something into energy. So the argument here, again, to go back to what is being argued. So that was the nature of the two disputes. The one dispute was that you can't have this pressure system because momentum's going to screw it up, and that argument's defeated by the fact that photons don't acknowledge momentum, just as gravity doesn't acknowledge momentum. Gravity is exactly the same whether the Earth is traveling. The moon is going to stay with the Earth no matter what speed the Earth travels, in the sense that gravity is still going to be the same no matter your momentum. No matter which way the sun moves, the gravity isn't going to change on all the planets because they're moving in a direction the sun is moving. So you can't change gravity by giving something momentum. And the explanation for that is that the gravity is made out of photons, and photons don't acknowledge momentum because they don't see it. They just see fish. They just see photons trapped in electrons that they interact with. So the only thing they interact with are the photons inside of electrons. So again, I do believe that the nature of photons, to give you a quick description, is that all the photons are the same. So from radio waves to cosmic rays, it's all the same photon. All you're changing is the distance or the period between incidences of the photons. And so radio waves have a lot of photons in wide periods. So there's a large P between the photons, and there's lots of photons, but they're spread out. And something like a cosmic ray would be a stream of photons with a very small period, very close together. And so these two things could have an equal energy, even though the energy is going to be imposed on a smaller surface. Obviously, it'd be spread out over a larger area, and that's the real difference. You are only going to perceive a tiny fraction of a radio wave, while you might end up getting the impact of an entire stream of cosmic rays. And so they're going to be called high energy merely because the energy is focused. It's going to hit a narrow piece of territory rather than a wide territory. And And so, again, so we're back to the idea that they're just fish. All the fish are the same. They're all just moving the standard speed of light. And all that we're really talking about is how the fish are patterned. What kind of period is between them. So I'm basically arguing that it didn't matter. It's likely that the photons have no period, that they're actually right next to each other. And that the nature of what takes place is that photons come in at a frequency, and photons will be leaving at almost any frequency dictated by the structure of this pattern. So any kind of energy can come into an electron, and the electron can always produce blue light or something. It'll produce the same thing over and over again based on its configuration, based on the size of its orbit, let's say, or the speed of its internal spin. So it has maybe 2 or 3 components or properties that will dictate what it produces. Now, why I wanted to bring that up, not entirely sure. Okay, but so let's go back to the gravity argument. So just understand again that there's 2 things you can change: is the direction, and that you can do without any energy transfer, or you can change the speed, which will require essentially a consumption of some portion of energy. So in a sense, what would happen is a photon would have to be absorbed by the thing that's going to move faster. For this to wobble faster in a direction, it has to absorb a photon to do it, probably, and something like that. And that would just mean that instead of that the photons would come in at a period of 4 per, and they would leave at 3 per some given point of time. So that would be the difference. They absorb one for every 4 that come in. They absorb 1 and change light from blue to red. So they collect blue light and give back red light and keep the extra photon, essentially. And that's the transfer of the energy, and that would be realized in a accelerated speed. So you can sort of understand that if I have an ellipse and it's moving in a direction, and I enlarge the ellipse, that I will accelerate the speed at which it moves, because now it will be eating even more space with each rotation. So I'll be changing how much space it eats by changing its size. And so that makes sense. It makes sense that photons are consumed by electrons. Electrons expand in size. When they expand in size, they expand in directional velocity. And that would be, that could create heat. What I'm arguing with gravity is that that doesn't happen, that it doesn't expand, that they are never absorbed, because it is purely kinetic. And so the only thing ever changed is the angular momentum, or the shape of the ellipse. So when these photons, these gravitons, whatever you want to call them, the photons that are what I would guess are wide wavelength photons, that are photons like radio waves. They are very, very many of them, but they have a wide wavelength which is indistinguishable to the electron. The electron doesn't consider it even a pattern of arrival. It just considers them individual photons. There's such a wide period between their arrival. So they're just considered random photons. And anyway, they come in individually, essentially, so they can have no accelerating impact. They cannot be absorbed because they're not of a proper frequency to allow absorption. And so all they do is change the shape of the ellipse by impacting and create an exchange of angular momentum. So let's say one of these pressure photons is coming in from this direction, and this is the gravitational body, that's going to be gravitationally pulled by the shadow created by this thing. So anyway, it gets a little bit complicated because I'm using they can come in from all angles. They're coming in from all angles, and what they're doing is being shielded. This is being shielded from this pressure, and this is being shielded from this pressure from this body. So that's the attraction that's pulling these two items together, is the shielding that's created. And the shielding is created by this idea that the photon comes in here and it leaves at a different angular momentum. So this photon comes in this way, and it interacts with the electron, changes the ellipse shape, tending it to be more elliptical in the direction of the momentum, which is its momentum. So it basically exchanges some portion of its forward, so the forward momentum is exchanged for, it loses that forward momentum, comes off at some angle, a scatter. It scatters, and by scattering it extends this forward momentum. This pitch is now given to the ellipse of the electron. And so the ellipse of the electron is changed in exactly that proportion from, say, if it was going in this direction, now it will be going in a forward direction. Or if it was going in the left direction, it would be going less left. Or if it was going this way, it would be going less that way and more forward. So it's just going to in some way tend to bend it in that direction. So so anything from this parallel on, it's going to tend to make it leave in a direction more forward. Not necessarily directly forward, but more forward. So it's just going to exchange its angular momentum. And this is completely consistent with Feynman diagrams regarding quantum mechanics and the exchange of angular momentum that takes place between photons and electrons. So this is so it's to be understood. All the energy that goes in, all the E that goes in through this gravitational pressure comes out as scattered. Okay, so the same exact photons come out that went in. They just come out with a different angular momentum. Alright, so it's exactly the same thing. And all they did was exchange some portion of their momentum for the momentum of the individuals in here, which now changes their net pressure in this direction. So essentially what's taken place is there was fish in all kinds of different directions, moving in all kinds of different directions, and the pressure pushes the fish based on what pressure it's being exposed to. And so if there's a gravitational body shielding this side of the pressure, so no pressure is coming from this direction, then all these other pressures will be tending to move the fish in their direction. So the tendency would be, this would be the bulk of the pressure would be in this direction, a parabola to the gravitational body. And the tendency would be that these fish would all be bent a little bit more in that direction, and by bending them all a little bit in that direction, you would change the wobble in the direction of the gravity, and the two bodies end up gravitationally being pushed into each other by this pressure force, that's converting angular momentum. So this is fitting very nicely, and again, this is totally applicable to magnetism if you just create the option of having a conversion that does take place where the photon that goes in, the photon plus comes out, or whatever you want to call it. A photon minus goes in, it's converted to a photon plus, and vice versa. So the negative pole takes a photon minus and turns into a photon plus. The south pole takes a photon plus and turns into a photon minus, and the same effect as this gravity effect is accomplished. And so there is no heat generated because it's just changing angular momentum. It's not changing velocity of electrons. It's just changing their direction of their wobble. And there is no problem with any kind of momentum issue, because momentum is irrelevant in the interaction of photons. Photons react to photons, and they only react to photons trapped in electrons. That's the rule. I think there's good reason for that rule I don't want to go into an explanation for, but it's a rule of the kinetics that you can you don't have a pure kinetic exchange when you're. If I had pool balls lined up in a direction, but they weren't moving, and I hit one pool ball going in this direction into this pool ball, what'll happen is this pool ball will just fly off in this direction. But that's if these aren't moving. And the trick is that in photon interactions, this is actually what happens. From a photon's perspective, the other photons aren't moving when they actually interact. So they have a purely kinetic interaction. But the catch is, when they are in electrons, I think the bond between the photons creates a problem. So now that there's no distance between them, when they're free electrons, when you shoot like gamma rays at ultraviolet light, you're not going to get any interaction because there's separation between all of the pool balls. There's distance between all of them. They're not tied to each other. They're just separated by distance. So everything's going to be kinetic. All interactions with them will be kinetic, purely kinetic, as if they were standing still. But when they're tied to each other, you can't hit this one without affecting this one and this one. And that's where angular momentum gets into the issue, and where now you're going to change the force impact, because you're going to be bending or in some other way physically disrupting, and you're not going to be able to leave at the same angle. You're going to leave at a different angle, and you're going to impart that loss of energy or that loss of direction onto this body by changing or distorting or perverting its shape, or in some other way changing its angular momentum, not changing its energy, just changing its movement. So it's like the difference between you bang into a fish and you cause it to move a different direction. It's still moving the same speed, still doing exactly the same thing, so there's no exchange of real energy. Alright. But the school itself can be caused to migrate faster if you push enough fish that way. Yeah. Alright. I think that's enough. So anyway, this is looking just too good. Makes too much sense. Yeah, it's just too... yeah, I really like it. So yeah, I just have to make it, more visuals, give you some graphics, make this more palatable, I suppose. But I think it's right. All this dilating space stuff, again, you just don't need to do that. You don't need to dilate space and time. We can explain it with mechanical forces, and again, the understand again what causes something to time dilate is just that if you have fish and they can only move 30 miles an hour and they're caught up in a pattern doing this, that if they move in a direction, if the whole figure 8 moves in a direction, that means it has to take them longer. They have to travel more distance now, because now they're going to be figure 8ing over here. And so it's going to take them longer and longer to figure 8, because they have to eat more space in the direction they're moving. So you can understand where velocity would change direction. You can also understand the difference between acceleration and velocity, and why electrons must be in their native state tend to eat space in a direction as a mechanism for acquiring velocity, is that there has to be a general wobble in a direction that's possible. And this is why, though, that velocity would have to have some limits before you start to break down the structure of the atoms themselves, especially for complex atoms, and certainly for chemistry. The chemistry would have little hope of surviving high velocities, because this movement in a direction, if it got too high, would just break down the ability to maintain the patterns built into the matter. Okay, enough. So till next time, and such.